In this video, I'm going to go through question 2 of my tricky parts per notation questions. Question 2 reads, blood cyanide levels above 3 milligrams per litre generally result in death. Write this concentration in a parts per notation with a suitable magnitude, e.g. parts per billion, parts per million percentage, and fraction, e.g. V over V, W over V, etc. Now we're told that the concentration of cyanide that generally results in death is 3 milligrams per litre. So we can write this down as follows. Now, if we look at the units of this concentration carefully, we have milligrams over litre. Milligrams over litre. Now, milligrams is a unit of mass, with which we're going to use the symbol W for. And litres is a symbol for, or a unit of volume, which we're going to use the symbol V for. So you can kind of see we've already kind of got W over V already. So it wouldn't really make sense to convert this to any of the other fractions like V over V, N over N, W over W, etc. So let's keep it with W over V. I think this makes the most sense. We don't have to carry out any tricky conversions using density, for example. Now that we've chosen a fraction, we need to make sure that the units of this fraction are in the right units for the parts per notation. Now, the W over V fraction for the parts per notation has units grams, centimeter cubed, which is the same as grams per milliliter. So we need to go from 3 milligrams per litre to an equivalent number in these units. So the first thing we need to do is convert the milligrams to grams. Now, to do this, we know that if we have 3 milligrams in a litre, if we want to find out the equivalent amount of grams in a litre, we're going to have less grams than milligrams because grams is a bigger unit. And now there's a 1,000 times difference between a milligram and a gram. So that means our number, the 3 here, is going to decrease by 1,000 times. And 1,000 is equal to 1 times 10 to the minus 3. So the concentration of cyanide is equal to 3 grams at 10 to the minus 3 grams per litre. Okay. Now we've got the grams, or the weight part of the fraction, in the correct form. We just need to get the litre part in the correct form. Now, if we've got 3 times 10 to the minus 3 grams in a litre, remember a litre is quite big. If we've only got 1 milliliter, we're going to have a lot less grams in that milliliter than in the litre. And because there's 1,000 milliliters in a litre, that means we're going to have 1,000 times less grams in a milliliter than a litre. So again, we need to divide by 1,000, and this turns the number in standard form from 3 times 10 to the minus 3 to 3 times 10 to the minus 6 grams per milliliter. Now these units are in the correct form for the W over V parts per notation. So now we need to choose the correct magnitude. So for parts per billion, we times this number that we've calculated by 1 times 10 to the power of 9. For ppm, we times it by 1 times 10 to the 6. And for percentage, we times it by 1,000. So let's do this for each time. So if we times by 1 times 10 to the power of 9, we'll have a parts per billion of 3,000. If we times by, we'll just give that the correct units, so 3,000 parts per billion. Now, if we times by 1 times 10 to the 6, we will have 3 parts per million. If we, this should be 100 here. If we times by 100, we will have 3 times 10 to the minus 4 percentage. So you can see quite straight away that this number is still quite tricky to deal with, because that's why we use the parts per notation. We're trying to make the number a bit more manageable. 3 times 10 to the minus 4 doesn't make that much sense to people because it's a really small number. So we're going to cross that one out straight away. Now, 3,000 is not a terrible number to work with, and 3 is probably a little bit better than 3,000 because it's a number between the values 1 and 10. So I think here that parts per million is going to beat out parts per billion just because 3 is a little bit more manageable than 3,000. So what we're going to do is we're going to cross out 3,000 parts per billion. And that means that this is going to be the correct magnitude for our parts per notation. So our concentration of cyanide in parts per notation would be 3 parts per million W over V. And this answers our question.